Thank you very much. My name's Gavan Fantom, and I'm going to be talking to you today about hobby electronics like a pro. Now, the world of electronics has moved on quite a lot in the last few decades, and as the giant corporations who make millions or billions of electronic devices have been enjoying the progress of the last few decades, as hobbyists we can benefit from this progress in technology as well. There are a few key differences, but the technological improvements and the process improvements are coming through to us. So what I want to talk to you about today is, if you're a hobbyist, if you're making electronics, I want to give you an overview of the kind of things that are available to us nowadays. I only have 30 minutes here, so I'm not going to be giving an in-depth tutorial on all the tools and all the processes here. I will warn you about that, because otherwise we will still be here at sundown. However, the fact that it is an overview means that if you are not a hobbyist, or are not a hobbyist yet, and are not into every last little detail of electronics, this is probably good for you, because this means you have a chance of following along as well, because you are also part of my audience, and I would really like to give you an overview of how things work, so that you have maybe a bit more appreciation for what goes into an electronics project when you see one. So fundamentally, at the really basic level, making a piece of electronics comes down to this. You have a bunch of components, and you are trying to connect them together by wires, bits of metal that will conduct electricity. Right, and that holds true for many hobby projects. It gets a little bit complicated when you have high frequencies involved, but let's ignore those for now. And taking that quite literally, you can end up with this. Now, this is actually a perfectly valid construction style. It's called dead bug construction, because when you take a chip and you flip it upside down with its legs pointing into the air, it looks a bit like a dead insect. It does the trick. It works. This is not my project. I found this on the internet, but there are lots of examples of these all over the place. But the one thing it doesn't have is that kind of professional look. So many hobbyists will be more familiar with this kind of stuff. Again, another picture I found on the internet. This is a piece of strip board. And what you can't see, but is on the other side of it, is every row is connected together just with a strip of copper. And so you have this kind of thing with all the components lined up vertically, connecting different rows together. And you can cut the tracks to make the circuit that you need. Now, this is quite a useful method of construction, because you don't have to think too hard about it. You have to do a little bit of planning just to figure out where the components are going to go. But it's not something you have to plan weeks in advance. It's not something you have to have special tools for, apart from a soldering iron. So a lot of people will have started out trying to make things on stripboard. I've made a whole bunch of stuff on stripboard myself. I'm sure some people in this room have as well. And if you're going to stick it in a box or something at the end of the day, there's no reason not to just run with it. But we can do a little bit better than that. Again, a picture I found on the internet. This is how to get started with making a circuit board that's a custom circuit board with just your circuit on it, and not one that's been pre-printed in strips. And this is typically done with some sort of etch-resist pen. I think this particular one was done with a Sharpie, but you can spend about 4 times as much on a proper etch-resist pen. And the idea is simple. You have a copper-clad board, you draw on it with the pen, and then you dunk it in a vat of nasty chemicals, and it etches away the copper that you've left alone, and the stuff that you've drawn on remains. So it's a fairly simple process. But it is a bit messy if you do it this way. It relies on having good drawing skills, and the intersection of people who are into electronics and people with good drawing skills is limited. So we can do one better than that. This is an ultraviolet exposure box with a transparency on it. Now what you do with this is you get a copper-clad board similar to the one in the previous slide, but this one has a special photosensitive coating on it. And you put it on top of the transparency, you close the box, you expose it for a certain amount of time. And the advantage of that is that the transparency can come straight out of your laser printer. So that gets rid of the problem of having to draw lines accurately. There's still one thing that is a pain in the backside with this technique, though. For most circuit boards, at some point you're going to need to drill holes in it. And this is especially true for your earlier projects and for the smaller ones where you're using the traditional through-hole technology, which is where you have components with bits of wire sticking out of them, you poke them through holes and then you solder them. Somebody's got to drill the holes. And I don't know about you, but I find drilling holes accurately, especially very tiny holes in the middle of a tiny bit of copper, quite tricky. So I've missed out quite a number of different construction techniques because that's not really the key point here. There is a technique that we can use if we do a bit of planning ahead that is becoming accessible to us. It has become accessible to us as hobbyists. And that is to get a PCB made commercially. Now, in the past, that's been something that has been a very expensive proposition. And, you know, for many years, I discounted it as, wow, I really can't afford this, not for something that I'm just going to make a couple of and it's just going to be a project that I'm never going to use again. But the economics of this has changed. These have come down in price, and it's now viable to get a small-scale project made commercially. Okay. This one is a project that I made recently, and it took a couple of weeks to get it shipped over from China, and it cost me probably about $20 for the boards. So if you're going to make these commercially, or even if you're going to use the ultraviolet exposure method, you're going to need to go somewhere, you're going to need to do a bit of preparation. Most of us have started out drawing circuit diagrams on a bit of paper, and that's great because it helps you understand the circuit that you're designing. I'm not going to give you a tutorial on how to design the circuits here, by the way. The internet is full of them, and I thoroughly recommend that you go and spend some time on that if that's something that you're interested in. But we can go one step up from doing it on paper. Maybe draw out a sort of concept sketch on paper first if you want. But most of us have computers here, and computers can help with this. So this is a screenshot from my laptop from yesterday with a project that I made. This is the schematic diagram for it. It's, let's say, moderately complicated for a hobby project, but it's not actually that complicated. It's got two chips that do anything substantial and a few components dotted around the place. This would be quite difficult to draw out on paper because you'd start out putting things down and then you'd realize you need to connect something from over on the left side to over on the right side. And you start drawing lines all over the place and you'd be through 3 or 4 drafts before you got anywhere. So it's quite useful to have a go at using these tools. Now there's a number of different tools available. This one is an open source tool called KiCad. It is not the only tool available. There are commercial tools, there are open source tools with different learning curves. Most of them, because they are a kind of specialist area, most of them do have a bit of a learning curve, but it is worth putting a bit of time in there to actually learning how to do it. Again, there are loads of tutorials around for pretty much every single package out there, and I thoroughly recommend if you want to have go with one of these, read some of the tutorials. They will help you a lot. So what can you do with this that you can't do with paper? Well, obviously, we can edit things without having to redraft it all. Because it's a bit neater, I find that it makes it easier to spot mistakes. If there's something not quite right, I can see it more clearly on the screen than I'd be able to see it in among sort of 30 scribbles on a piece of paper. The software can also help you out here because it can tell you, you've forgotten to connect this pin to something, or this power supply here isn't connected to anything. Are you sure you've powered your circuit? And if you're doing things with a computer, one of the things that is the bane of the music industry is the fact that it is easy to copy things with a computer. It is easy to take a copy of this and put it on your website. It is easy to take a copy of this and send it to your friends. It is easy to put it on GitHub and open source it. It is also easy to print it out multiple times. It is also easy to have your designs manufactured more than once, which is something that if you're drawing things out on a PCB with a pen, it doesn't scale. And you can use this software to draw your circuit diagrams, even if you're not going to go all the way to making a printed circuit board with it. Even if you're going to go with Veriboard, stripboard, or any of the other construction techniques, it will help you get your circuit right before you commit to the making of it. Once you have your circuit diagram in this form, you can start the job of turning it into that. Now, this is a fairly messy picture because it has all of the layers of this circuit board. This is the same project as in the previous slide, but the software will help you get it right when you do this. So you can show only limited layers. So this is a 2-layer board. It has wires on the top and wires on the bottom. And it has holes which are plated so that they can connect wires from the top to the bottom. They're called vias. And it also has bits of writing which will come out on the finished design as a silk screen so that you know when you put it all together which component goes where. It's a lot easier than if you don't have that and you just have to try and keep going back to the diagrams and the drawings. One of the key things that this kind of software will help you with is it has a thing called design rule checking. The manufacturer of the printed circuit boards will have certain limits of how thin they can make the wires, of how thin they can make the holes, how far away they have to be from each other. And the software can help you because if you tell it what the rules are, it can tell you this bit doesn't comply, you need to fix that. Or if you're really lucky, just not even let you put things there in the first place. So again, I'm not going to go into the details of how you run this bit of software. There are many bits of software. This is, again, part of KiCad. There are many alternatives, and I thoroughly recommend you check them out, as well as all of the tutorials. Once you have this layout done, the final step with your software is to take that and export it to Gerber files. These are the files that most of the manufacturers will take, and pretty much all PCB software will allow you to export into this format. So, this is what a traditional PCB manufacturer looks like. They deal with massive operations, large scales, and they're not really going to talk to me or to most of you when we come along and say, right, I want 5 PCBs that are 5 by 5 centimeters. This is what the factory would look like for somebody that's producing thousands, tens, hundreds, thousands, large scales, and pretty large circuit boards at that. The thing that has made it possible for us to do this is really twofold. One is that large companies also need to do small production runs. Before you make 1 million items, you want to make a small number first to make sure they work. Right? Fundamentally, you don't want to throw your 1 million away when you find that they're completely broken. So most PCB manufacturers will have some sort of facility for prototyping. And that, for a large company, might mean they make 50 or 100, something like that. Maybe even 10 if they're a slightly smaller company. Now, we can benefit from this. The other thing that has made it possible for us to do our small hobby projects is that there are outfits out there who will take small projects from me and from you and will aggregate them onto a larger PCB and will then send them to a prototyping house. They will charge a bit of a premium for this, but it means that you can get your 5 small circuit boards rather than 100 big ones. So this kind of PCB pooling service has really transformed the market and really made it accessible for us. The other thing that has helped a bit is more on the economic side than the conceptual side. This is a picture of one of the many electronics markets in Shenzhen, in China. And Shenzhen in particular has quite a vivid economy and ecosystem around the small-scale electronics design industry. And they have a number of companies who will take really small-scale designs, will do the PCB pooling thing, send them to their prototyping houses, and are often considerably cheaper than European or American outfits. So we are now at a position where you can go and send a design to a company in Shenzhen, and for $10 plus a little bit for shipping, you can have 5 or 10 boards made. Fairly small ones, but that's a lot cheaper than the, maybe you'd be spending 30 or 40 pounds or maybe 50 pounds or something like that if you're doing it locally. And one thing that I'm always surprised that people haven't heard of this when they've already been sending PCBs out to places is this website. This is PCBshopper.com. I'm not affiliated with them, but I have used them. They are a comparison site for PCB manufacturers. They will compare not just the ones in China, the European ones, the American ones as well. And you fill in the form, put in your requirements, including whether you care how quickly they arrive. They will do this for PCB manufacture, and they will also do it for assembly if you want them to put the components on the board for you. I'm going to talk a bit about assembly shortly, but there are services there that can do it for you as well, and they will point you at the cheapest or the most reliable or the fastest, whichever you want. So I can definitely recommend PCBshopper.com, because once you've got your designs, that will find the most suitable manufacturer for you. So you've used this site, you found a manufacturer, you've spent all night finalizing your design, the sun's coming up, you've sent off your design, you go to bed. Okay, great. A few weeks pass, and then you get a package in the post. It's a very exciting day, that is, especially on your first time. And So that one's 5 PCBs. Well, it's actually 6. They chucked in an extra one for free. It's nice of them. And so what do you do with that? So you've had a few weeks to think about it. You've gone to whichever supplier you're using for your components. You've ordered all the components. In this case, an absolute bucket load of LEDs for a little sign. And it's time to start soldering them. Well, okay, that's one way you could do it. If you're doing an entirely through-hole design, that's what you will end up doing. There are techniques for doing soldering on a large scale called wave soldering. Almost nobody does that at home because that involves having a vat of solder that's heated up to a few hundred degrees and having a wave traveling through it and dunking your PCB over the top of it. That's a bit fiddly to set up, and it's only really worth doing if you're doing large scale. So through-hole designs, you will be using your soldering iron, such as this one. If you have decided to venture into surface mount components, that's components that don't put a wire through the hole, they just have little bits of metal on them. They're usually very small. The advantage of them is that you can get so many more into the same area. You'll have little bits of copper on the circuit board that are just exposed in the right place, and you stick them on the surface without putting anything through the board, such as this board. You can solder them with a soldering iron. It's a pain in the backside if you've got lots of small components. You can do it relatively easy with chips. There are some techniques. The most common one for dealing with a chip with lots of pins is to put the solder down on the pads, and then to drag the soldering iron down the row of pins. When you're doing through-hole things, they normally teach you solder one thing at a time, which is absolutely the right way to do it for through-hole. But you do have a few techniques like this that can do things quite quickly with surface mount components. But there is an easier way if you have the tools for this, and that is to get some solder paste, which is literally what its name implies. It's a fairly thick paste of teeny tiny beads of solder with flux in them, and you put a small amount on each pad. There's a couple of ways of doing that. One, you can use a syringe. It's quite difficult to get the right amount, but a bit of practice will get you there. And the second one is, when you have your PCB made, tick the box that says, I would like a stencil as well. It's a thin sheet of metal, or sometimes Kapton or something else, and you put it on the circuit board, you line it up, and you get a solder paste tool. The cheap version is an old credit card, and you just wipe it over, and that gets you a very consistent amount of solder in all the right places. And then you put it in an oven. Now that one might look a bit homemade. That's because it is. This is the one that I made for this purpose. They come in all shapes and sizes. You can buy them off the shelf, but some of them are rather expensive. If you have a large-scale outfit, they will have a reflow oven that is enormous, and it will cost tens or hundreds of thousands for the really big ones. As a hobbyist, that's not really much good. Also, you probably don't have enough space in your house for it. But you can get, again, for prototyping purposes, you can get them for a few £100 as a proper reflow oven with the controller in and everything. I decided not to go that route. I thought it would be more interesting to make my own. I bought this oven from a high street shop for 30 quid and started hacking it. The critical bit about the oven, the real difference between this and a domestic oven, is that you have something a bit like this. This is the project that I showed you the schematic of. This is a controller. And it measures the temperature of the oven near the circuit board, and it will take it through a temperature profile. This is quite important so that you can solder all your components down properly without burning anything. Now, you can probably imagine that the results of this might come out differently from hand soldering things. This is a comparison of a board that came straight out of the oven, and the other board is also one that's been through the oven, but it went through the oven before I'd figured out the right amount of solder paste to put on it, and so I had to rework almost every single one of the LEDs. Now, I used a solder which has a flux in it which leaves a bit of a residue so that you can see it's a bit messy. And I put these side by side just to show the difference that it makes to really get the reflow process right, rather than having to do it all by hand. They both work, they both do the job, but one is, let's say, more professional than the other. And there's one more tool which is useful if you're reworking things, which is this. You can get these quite cheaply from eBay, Amazon, etc., from Chinese sellers. This is a hot air rework station. Despite the fancy name, it is basically a stream of hot air at a temperature that you can control and at a speed that you can control. So you slow it down enough, you're not blowing the components all over the place. And you set the temperature correctly so that you can melt the solder and not everything else. These are particularly good if you have a chip with, 48 pins on it or something like that, and you want to melt the solder on all of them and then pick up the chip with a pair of tweezers, because you're never going to get that right just going around all 48 of them with a soldering iron and hoping they haven't cooled down. So I hope that's been a bit of an overview of the techniques that we've been using. Once you've gone through all of this, you end up with maybe a finished product of sorts. Well, it's almost finished. There's one final step that you really want to do. Now that you've made yourself a circuit board that looks really professional, you can hide it in a box. This has been Hobby Electronics Like a Pro. I'm Gavan Fantom. Thank you very much for listening.